Hi, good evening, ladies and gentlemen. I want to welcome you. I'm Ibrahim, and I'm going to take you through the introduction to sets. I want you to feel free and enjoy this lesson. So, we are going to look at the introduction of sets, and just like I've told you, I am the presenter from Kabuko Secondary School and Chiterede Cluster Center in the Central Region. This small pic that you see is trying to show, or the image you're seeing is of a set. So, meaning of a set. A set is a collection of objects or members which are related in some way. Some sets or all sets have objects or members that are related in a given way. For example, we can have a set of names of human beings. So sets are denoted by capital letters. For example, you can have set A, B, name them, but they should be capital letters. You can also say a set is a well-defined group or collection of objects. And when you are dealing with sets, objects are often called elements or members. Sets, or when we are dealing with sets, we usually have what we call the curly brackets. I hope you can see them. So here I have an example of a set. We are saying A equals 468. Yes, thank you very much. Let us look at the terms used in sets, and one we are having what we call member or element of a set. And we are saying that these are the objects in a set. They are the ones that are referred to as members or elements of a set. Uh, for example, consider a set A which has 1, 3, 4, 6 as its elements. So we can say that 1 is a member of A, 3 is a member of A, 4 is a member of A, and 6 is a member of A. This is because we see 1, 3, 4, and 6 all belonging to set A. Thank you. Um, we also have what we call infinite sets, and these are sets with unlimited number of elements. In other words, under infinite sets, the number of elements in that set are, or you cannot count, you cannot exhaust them. You cannot count and finish. For example, we've given the following sets. We have W and R here. So we see W having whole numbers. We cannot exhaust whole numbers. Likewise, R has real numbers. You cannot exhaust them. M has multiples of 3. So there are many. You cannot count all of them. So all members of these sets cannot be exhausted. So they are called infinite sets. So we have what we call equal and equivalent sets. So equal sets, two or more sets are equal if they contain the same elements. For example, we have set A given as 1, 3, 5, 7, and B it also has 1, 3, 5, 7. So here A is a subset of B, and also B is a subset of A. In other words, these two sets A and B are equal. So we also have what we call equivalent sets. Two or more sets are said to be equivalent if they contain the same number of elements. For example, given that set A has R, A, E, or U, and then B has 2, 4, 6, 8, 10. When we count here the number of elements in A, they are 1, 2, 3, 4, 5. But also the number of elements in B are 1, 2, 3, 4, 5. So meaning that A and B are equivalent because they contain the same number of elements. Therefore, that's why we call them equivalent in sets. Still, we also have what we call union of sets. Is noted by this U. The union of two sets is the set of all elements that are members of either set. The symbol is here. We have an example here that given M as 1, 2, 3, 4, and then N 3, 4, 6, 7, and we are tasked to list the N union M. Automatically, we have 7, 6, 4, 3, 2, 1. In other words, it's like bringing all these elements minus repeating them into one set. Lastly, we are told to find the number of N union M, and it's just a matter of counting this one that we have already listed above, which are, in this case, 6. Um, so we have what we call disjoint and the complement of a set. So when we talk about disjoint set, in this case, when the intersection of the two sets is empty, the two sets are said to be disjoint. For example, given P as 1, 3, 5, 7 and Q as 2, 4, 6, 8, here, the moment we try to find the number of P intersection Q, it is a 0. And in this case, therefore, P and Q are disjoint because they don't have any anything that is in common. In other words, the intersection is 0. Then when we talk about complement of sets, we are having A given A as A B C D and B as A B C D E F. So members which are present in B and not present in A all the complement of A, and they are noted by A complement. So from the above two given sets, we tend to realize that A complement in this case will be E and F, because they are the elements that are not in A. Thank you for watching. I wish you good luck.